Hi, this is Brandon Baines, the Math Department at Lipscomb University, here to talk with you today about X-intercepts and Y-intercepts. In this presentation, you'll learn the definition of X-intercept and Y-intercept. You'll also learn how to find the X-intercept and Y-intercept of a linear function. An X-intercept is an ordered pair in which the graph of a function crosses the x-axis. X-intercepts always have a y value of 0 because it's an ordered pair directly on the x-axis, so there's no vertical rise. So the y value will be 0 when we identify our x-intercept. The y value is the ordered pair in which the graph of a function crosses the y-axis. Y-intercepts will always have an x value of 0 because it's an ordered pair directly on the y-axis. It has no horizontal deviation. It's still on the y-axis. So anytime we identify a y-intercept, we know that the x value will be 0. We can identify the x-intercept and y-intercept of a linear function graphically. We have a graph of a linear function below, and we can see here that the graph crosses the y-axis here, and that the graph crosses the x-axis here. And if we identify these points, we'll see the x-intercept here looks to be about the ordered pair 1/2 or 0.5, 0, and the y-intercept, this point here, appears to be the ordered pair 0, 1. We can also identify the x and y intercepts using an xy table. Again, keeping in mind our definitions and some of the things we said there when we defined x-intercept and y-intercept. We said that x-intercepts always have y values of 0, and so we should always be looking for ordered pairs of the form x, 0. And we also said that y-intercepts always have x values of 0, and so for that reason, we'll be looking for ordered pairs that look like 0, some y value for the y-intercept. Below we have the xy table for the function f of x equals 9x plus 9. As we examine this xy table, we do see that the ordered pair -1, 0 is on here. This has a y value of 0, and so we know that it must be an ordered pair that's on the x-axis, so it is an x-intercept. We have the ordered pair 0, 9, and again, since the x value is 0, we know it must be a point that's directly on the y-axis, and so it must be a y-intercept. Should be noted that from some of our previous presentations, we would know that 9 is the y value of the y-intercept because of this 9 in the equation. Remember that our linear functions follow the form mx plus b, where b is the y-intercept. We can also use equations to find the x and y intercepts. Again, it all will go back to the definition, really. When we look at an x-intercept, we know the y value should be 0, and so we'll let y be 0 and solve for x. If we're looking for the y-intercept, we're going to let x equal 0, and then we'll solve for y. Here's an example of doing that. We have the function f of x equals 1/2 x minus 3. To find the x-intercept, we'll let y be 0. So that's going to result in the equation 0 is equal to 1/2 x minus 3. Proceeding to solve for x by adding 3 on both sides. and then multiplying by 2 on both sides gives us the solution x equals 6. So we know the x-intercept is the ordered pair 6, 0. The y-intercept is 0, -3, which we actually know that from looking at the definition of linear function. Again, this is mx plus b, where b is the y-intercept, so -3 is our y value of our y-intercept.